In this video, we will do some College Board multiple choice questions pertaining to inverse trig functions. This is AP Precalculus Topic 3.9. If you appreciate the content, please give it a like. Number 1. The function f is given by f of x equals 1/2 sine x on the closed interval between negative pi over 2 and positive pi over 2. What are the domain and range of the inverse of function f? Quick side lesson. If f of x has a domain from a to b and a range from c to d, then the inverse of f will have a domain from c to d and a range from a to b. In other words, the domain and range are reversed for the inverse function. When they say that f of x is equal to 1/2 sine of x for the interval between negative pi over 2 and positive pi over 2, this interval is the domain. These are the lowest and highest input values. To find the range of f of x, we need to find the highest and lowest value of 1/2 sine x. But let's start by finding the range of plain old sine x. We know that sine is the y value on the unit circle, and therefore sine has a high of positive 1 and a low of negative 1. So the range of sine x is negative 1 to positive 1. We can find the output values of 1/2 sine x by multiplying each of these output values by 1/2. So the range of f of x is negative 1/2 to positive 1/2. For f inverse, the domain and range will be reversed. Since the range of f was negative 1/2 to positive 1/2, the domain of f inverse will be negative 1/2 to positive 1/2. And since the domain of f was negative pi over 2 to positive pi over 2, this will become the range of f inverse. So the answer is A. Number 2. The figure gives the graphs of 4 functions labeled a, b, c, and d in the xy plane. Which is the graph of f of x equals 2 arc cosine of x? Remember that arc cosine is the inverse of cosine of x if we first limit the domain of cosine to the interval from 0 to pi. Also, remember that the range of cosine goes from negative 1 to positive 1 as always. Inverse functions have the domain and range reversed compared to the original function. So arc cosine has a domain of negative 1 to 1 and a range of 0 to pi. We can identify the graph of 2 times arc cosine if we know the domain and range. Compared to arc cosine, multiplying by 2 in the front is a vertical dilation by a factor of 2. A vertical dilation only affects the range and not the domain. So 2 times arc cosine should still have a domain that goes from negative 1 to positive 1. To determine the range, we just multiply these output values by 2. So 2 arc cosine will have a range from 0 to 2 pi. Looking back at the graph, we notice that this curve is the one that has a domain from negative 1 to positive 1 and a range from 0 to 2 pi. So the answer is C. Number 3. The figure above gives the graphs of the functions f and g in the xy plane. The function f is given by f of x equals arctangent of x. Which of the following defines g of x? All of these functions are transformations of arctangent. In other words, all of these functions are transformations of f of x. So let's try to figure out what transformations of the function f would give us function g. Begin by focusing on the point of inflection, which on the graph of f is right here at the origin. On the graph of g, that point of inflection is here at the point 0, 1. This tells us that there is a vertical translation by 1. But are there any other transformations? Notice that the distance between the vertical asymptotes has not changed, so there is no vertical dilation and there should be no number in front. To figure out whether there are any horizontal dilations, it's useful to start with a point that is right on the grid lines, like this point right here at 3, 2. So notice that the input value is 3, and notice that this point is 1 unit above the point of inflection. So if I look at the original graph f, and I go 1 unit above the point of inflection, that level intersects the graph right here at what appears to be 1.5. So from F to G, this point went from a horizontal position of 1.5 to a horizontal position of 3. In other words, this x value has doubled. So this is a horizontal dilation by a factor of 2. How will that show up inside the equation? So a horizontal dilation shows up as the opposite of what it appears. It shows up as the reciprocal. So if I have a 1/2 x, that will be a horizontal dilation by a factor of 2. And we still have the plus 1. F of x is equal to the arctangent of x. So that means g of x is equal to the arctangent of 1/2 x plus 1. This can also be written as the arctangent of x over 2 plus 1. So let's scroll down and take a look. And we see it right here, the arctangent of x over 2 plus 1. So the answer is C. Number 4. The graph of the sinusoidal function f is given in the xy plane. What is the length of the largest interval of input values of f on which an inverse function of f can be constructed? Remember that you cannot construct an inverse function on an interval where the output values repeat. For example, we could not construct an inverse function on the interval from 0 to 2 because that includes many output values that repeat, like these two. The interval from 1 to 3 is the largest interval I can create that contains no repeating output values. Because this interval has a width of 2, the answer is B. The function f is given by f of x is equal to 3 times the cosine of pi x on the closed interval from 0 to 1. Which of the following gives f inverse? If I think of this function as y equals 3 times the cosine of pi x, I can get the inverse function by switching x and y and then solving for y. So that's going to give me x equals 3 times the cosine of pi y. And now I would like to solve for y. Dividing by 3 on both sides would give me x over 3 is equal to the cosine of pi y. I need to make this cosine go away if I'm going to get y by itself. I can achieve that by taking the arc cosine of both sides of this equation. On the left side, I now have the arc cosine of x over 3. On the right side, arc cosine and cosine cancel each other out, leaving simply pi times y. To get y by itself, I will divide both sides by pi. So I'm going to end up with 1 over pi in the front. So f inverse is 1 over pi times arc cosine of x over 3. So the answer is D. Number 6. The figure gives a right triangle where y is the length of the side opposite angle A. If the function f gives values of a as a function of y, which of the following could define f of y? Y is the leg opposite angle A, and 12 is the hypotenuse. In geometry class, you should have learned that the sine of angle A will equal the opposite leg divided by the hypotenuse. So in this case, the sine of angle A will equal y over 12. To solve for angle A, we need to take the arcsine of both sides of this equation. On the left side, the arcsine and sine cancel each other out, leaving angle A. Angle A is equal to the arcsine of y over 12. This is the function we were looking for that gives the measure of angle A as a function of y. In other words, f of y is equal to the arcsine of y over 12. So the answer is D. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.